Hello and good afternoon. I'm Professor George Polyzos from the Athens University of Economics and Business. I direct the Mobile Multimedia Lab, and this is a workshop on cyber-physical ecosystems, how to build security, privacy, and trust in these systems, and create new business opportunities. This is a workshop that has been enabled by a European Union project, H2020, called SOFIE, that stands for Secure Open Federation for Internet Everywhere. So in IoT systems, there are many issues, but the way we see it, the most important ones are IoT fragmentation and security and privacy issues, and our project is set to address these mainly. So right now, most IoT systems and ecosystems are essentially vertically oriented silos, and this is for various reasons. Technical interoperability issues are the least of our concerns. Mostly there are business issues, counter incentives into having the systems interoperate, and also various privacy and security concerns. And our longer term vision is how to create technologies that will enable fourth generation business platforms, that is decentralized platforms that they will be open, and new players will have the opportunity to contribute with no barriers or very low barriers, and in a secure and creating trust among partners that have not cooperated or collaborated in the past. Distributed ledger technologies, blockchains, are enabling this. You're aware, and we have been hearing about those all day today. They come in different forms with very different capabilities, properties. And in our project, we try to take advantage of this wide spectrum of capabilities in blockchains and use multiple DLTs to achieve the goals we want. For example, we have at the same time open blockchains that create trust among unknown and unknown before partners. And we have permissioned blockchains that have very good performance and many other properties. And one key technology that we look into and we contribute and develop is Interledger technology, and I'll talk about this more later on. So the overall concept and the key ideas of our project is through federation, that is relaxed integration of multiple IoT ecosystems to create openness, security, and enable data sovereignty for the partners and the partnering systems. So the goals are through DLTs, through distributed ledger technologies, to enable secure and open federation of IoT platforms, interconnect diverse IoT systems, have metadata to be accessible in a controlled way, and have secure records in a secure way, audit trails for resolving potential disputes. There are 10 partners in the project. There are 2 academic partners, ourselves and Aalto University, and the other 8 partners are industrial partners. And we have 4 pilots, and we're driven by those pilots. So the project is not an academic project. We get our problems, ideas, and directions for solutions from those pilots. We have 2 energy pilots, one in Estonia with smart meters, another in Italy, where we are balancing the smart grid with electric vehicles. In Greece, we have a food supply chain pilot where we look at the provenance and the path of the food as it goes from a field to a fork. And we have Rovio with us, and we are looking at context-based mobile gaming, where we can have input from the real world into the cyber world of the games. So you will hear specifically, this workshop is about those 4 pilots. So the main thing that we'll do is go one pilot by one pilot, describing both how, but most importantly, why they use DLTs, blockchains, and what impact it has in their industries and what opportunities arise. Our design is based on the idea that we will not impact directly any of the existing IoT systems. That is, we plan to have new systems that will develop new technology that will be compatible with us, but they will be able to also interoperate with existing IoT systems by adding some converters, some federation adapters that we are designing and building. So, DLTs, they offer decentralized trust, immutability, transparency, and availability. Those are properties that we try to take advantage of. And Interledger allows the various DLTs that have different properties to interoperate so that we can have in the same ecosystem multiple blockchains, multiple DLTs, and make them securely interoperate, have nice properties about the whole system, but taking advantage of the properties that are appropriate for each one of those. So for example, you can have very low monetary cost in a permission blockchain and also extremely high performance, very quick transaction times, etc., and do some things there. And then if you need global trust, you also connect to something like Ethereum or something else that you can run smart contracts without having a closed set of players that can get into the game. Another technology that we incorporate in this architecture is decentralized identifiers, which don't necessarily have to rely on blockchains, but typically they do. And they get us free from depending on specific identity providers. And sometimes this improves privacy, but also flexibility in many ways, and robustness. So as I mentioned, Interledger is a key technology that we incorporate in our designs. And to give you some high-level, very rough idea of the general architecture we are considering is something like this. So at the bottom layer, we have IoT devices. Typically, we don't deal directly with those. One level up is IoT platforms that incorporate the devices. Those platforms can be completely independent, have different governance, different rules, etc. And this is an important starting point for our project. And we have those platforms be able to interact in various ways, exchanging data in controlled ways, even actuation with smart contracts. And we can have them either have, through permissioned blockchains, have very fast interactions, and in ecosystems that are predefined, that they know each other and they know the identities of participants. And when needed, either to get to other ecosystems that are unknown to them, or in order to have global trust, they interact with public blockchains, okay, of different types. And in some cases, they also use decentralized identities that come from another type of blockchain. Many times, Hyperledger Indy is one of the blockchains used in some of the distributed decentralized identifiers. And this is the overall design. So we have interledger technologies between public and private blockchains, among private blockchains, among blockchains for identity and for other data uses. Now, why Interledger? It allows the interconnection of otherwise existing operating ledgers. It can exploit the various properties of different types of blockchains, like performance, cost, privacy, etc. You don't want to put your data on a public Ethereum blockchain. They will be there forever. And also they allow the long-term evolution of blockchains, so that if there is a new type of blockchain that you want to move to, Interledger allows you to softly move from one environment to another and have them for a while operate in parallel. What does the Interledger function do? It can transfer information or value between ledgers. It basically listens to events on one and transports them, writes them on the other, or vice versa. And how or who performs these functions? There are various alternatives. It can be provided by a third party. It could be an existing entity that has presence in both blockchains or multiple blockchains. And it could be another decentralized system that touches both or multiple blockchains and makes the transfer of information or value. And in that case, you can have decentralization. So there are various technical things that I'll skip on how this is exactly done. One of the key technologies is timed hash locks. But if we have time, we can discuss it later. As part of the project, we have been looking at various setups where we are bridging the cyber and the physical world. I will not go through this because there are details in order to explain something, but we're looking at setups where either the clients are not connected to the internet or the devices are not connected to the internet. There is a separate authorization server. There are smart contracts that control everything. And you can have ways of enabling payment delegation and supporting many-to-one payments, etc. So you can have something like a rental car company that has essentially one wallet, sharing that wallet among all the cars that might need to do some transactions, for example, gets charged from the electrical grid. So what we will present in this workshop today are those 4 pilots that we have in our project. It's an energy data exchange pilot, an energy flexibility marketplace, the food supply chain, and the context-aware mobile gaming pilot. If there is a burning question that will help in the understanding of the whole project, I'll take it now. Otherwise, we'll have questions and answers after every pilot. And at the end, I'll be back up here to close and answer questions for the whole thing, which actually might be better understood after we go through the pilots. So if there is no burning question, I will introduce the presenters of the first pilot, Prit, Anton, and Margus, Haavala. Prit.
Thank you, George. It's working? Yeah. Thank you, George, for the introduction. So I am Prit Anton. I work in company Guardtime, and I am part of SOFIE, responsible for the energy data exchange pilot. And I think you have heard a lot about today about the cryptocurrency and tokenization. So George mentioned correctly that now we are going to go through about how we see the SOFIE project and blockchain and distributed ledgers can help in several fields in real action. So we are talking about the energy sector now, and my main job is business development in the energy sector. So not only it's about developing new innovation technologies during the project, but it's also how to bring them to the market and how to solve the market needs. So this idea of why we are doing this kind of research and product development in the energy sector is governed by, first of all, the regulatory drivers. So we have the EU Clean Energy Package and the GDPR that everybody knows of, but there are not so many that know how this will be used in various sectors. So what will be the technical solutions that can offer this kind of access to the data, security, and privacy of citizens. And of course, the sustainability of energy services and possibility to have new solutions to the market. This has both the regulatory obstacles, but also the technical obstacles. And we are here in SOFIE trying to solve some of those technical obstacles with blockchains and distributed ledgers. There is also a clear understanding that the energy sector will not remain as it is right now. So there will be a lot of new players in the market. And the race to offer these kind of new services ongoing right now. And big companies in the energy sector know that. So it's actually quite an interesting place to be right now in the energy sector. And of course, the most important, the end user, the data owner, the household or the energy production company owner, they need to have their interest protected as well. So we are taking a very good care of that in the SOFIE project. So what is the pilot about? So underneath we have the data sources, so we can't do without them. So we have the smart meter data, the production data, the consumption data either in the smart meter level and also in the national data hubs level. And what we are doing in the SOFIE is developing these SOFIE adapters that are put in place both in the data hubs and in the service providers' premises to enable these SOFIE components to provide functionality, being the identity authentication module, the privacy and data sovereignty, discovery and provisioning, and other functionalities that are needed for data access. And of course, in the up there is the end user side, the service provider side, that eventually, when the magic has been done in the bottom blocks, can access the data if it's granted from the data owner side. So it's like straightforward, and hopefully the vision that we have is that the seamless access to the data in Europe will be done by a few clicks from the data owner side, and then you have the intraday energy brokers, retailers, network operators that all can contribute and can actually be part of the new flexibility and energy market where the control button is on the data owner side. But to get from the vision to actually what we have done in the project, I will give floor to Margus Haavala, who will do a more detailed presentation of what we have in the project, starting with the concept. Thank you.
Thank you, Prit. Okay, hi everyone. I'm here to give a brief overview about the proof of concept solution we have made. We have different stakeholders in our system. We have the data owner. This is the real person representing the household where the smart meter is installed. Then we have different data sources. This is the place where consumption and production data is stored. It varies in different forms. It can be a single smart meter. It can be a nationwide data hub, as it usually in the Nordic countries. And it's also the case in Estonia, which is the first data hub we have onboarded to our system. But yeah, in other countries, they don't have yet smart meter, or the penetration is not that high. And we have electricity sellers or service providers. They are the parties that are interested in the production and consumption data. And one of the key components for our solution is the so-called federation adapter. This is the component that enables the data exchange. There's a lot of different features. It has identity wallet, etc., which I will describe later on. But we depend on some key technologies for our pilot. First one is decentralized identity. As you know, we truly are trying to build a cross-border data exchange. So we try to avoid the centralized systems, including centralized identity management. So instead, we are working on, I have implemented a self-sovereign identity management solution to our solution, which states that the data owner is at the center. You should have complete control where it shares its data and you can route data, et cetera, et cetera. And in the first phase, we have implemented or integrated a permissioned blockchain called Hyperledger Indy, which is very focused blockchain solution for identity management. But in the future, we are trying to build some kind of abstractions, so we are not really dependent on Hyperledger Indy so much. And the other key technology for us is KSI blockchain. KSI stands for Keyless Signature Infrastructure, but it's a global distributed pretty much hash tree connected to a calendar hash chain, and the network issues and verifies your KSI signatures. What it provides us, it gives us the integrity of the data. And it's really, really scalable. It's in production in many, many places. And it also has a nice feature of independent verification. In our case, we to sign all kind of events happening in the system in case later there's need to check the actions. So to illustrate the flow, I will show a simplified version from the data owner's perspective. Okay, everything starts with the wallet. Wallet is a secure place where the user can store its credential, it can share credential, she can revoke credential, etc. At the moment, here it's a web application, but we are working on a mobile application. It will give a much more better control for the internet owner. So when we start, the wallet is kind of empty, and in our case, what is needed, we need that we need a match between the real life identity and the digital one. So in ideal world, such issues would already exist in the system. I think in the future there will be, but at the moment we will use some kind of shortcuts, and that's why we will use our own authorization server that provide already proven authentication methods, strong authentication methods, and AEDAS compliant ways, which are country specific, but which allow us to issue credentials where the attributes say that this person has a national ID, et cetera, et cetera. So I think here you can see as a sample in Estonian case, we have different ways, but mobile ID is something we as Estonians have in our mobile device. It's on SIM card, and it's easy way to authenticate, and the signed documents is legal binding. And here you can see the authentication server issues a credential with attributes saying that the national ID is what it is, and based on this, and we need this match for the digital identity. And if the user has this credential, then it's possible to interact with possible service providers. Here we can see that I gave my consent to use my consumption data and production data. And you can see here that the timeline, the time that I gave the consent, the validity, and also I can revoke it. Just to demonstrate that I would revoke the credential. So, and go back, and I will choose another service provider. And now, when I've done the connection, in the background, we'll do a pairwise unique connection. It's secure, it's peer-to-peer, and service provider can now, in the background, fetch my production data, consumption data. This is just a sample that my product, here's just the consumption data. The red line is production data because I don't have, the user didn't have any production data available in Data Hub. And yeah, the service provider here is just an example where you can see different tariffs. Night is, day tariff is higher than the night tariff, but you can see, but yeah, this is just an example, but service providers, service providers, anybody who's interested in the consumption data. So from the data owner point of view, what's really important that okay, here we can show that I can revoke, and later on, if the service provider tries to fetch the data, I can't do it because I, as a data owner, have revoked it. And for me, as a user, it's really important that I can see the audit trail. You can see here that can show where I did give the credentials, where access was accessed, and when the access was revoked. And this is talking different things. We do take the KSC signatures for all the payloads, etc. And this gives the insight, the overview of the data owner. And this is such similar things with also about the other participants in the system. They will have such case. So that's all for the demo for my part. Thank you very much, and back to Prit.
Yes. So just to sum up the conclusions, so the authentication is really important because we are dealing with data owners that need to be known to the system, and the ADOS compliant authentication is something that we are using, and the combination between DIDs and authentication is something that we have proved. The data exchange through the SPID platform, that's an Estonian national data hub, and standalone start meters is proved as well. So we have data flow through these systems, and we are adding new data hubs and then potential networks to our pilot to prove the case in other fields. And yeah, the data owner control is something that we see that is covered in this case. So the next steps would be to widen the scope and add additional data sources there, and then also hear from you which are the specifics of the one or the other country about this opening up to the energy market and the energy data. So thank you very much, and now it's hopefully time for some questions.
There are some questions for Prit.
Or Margus.
Or Margus. Please.
Sorry, wait for a mic, yeah.
So my question is, if we bring blockchains to the real world, we need to have sensors, for example, to measure the data, right?
Yes.
So once the data gets in the blockchain, it's tamper-proof, but how can we make sure that the sensor is tamper-proof?
So there are two parts of the question I want to answer. First is that the data is not necessarily need to be gone to the blockchain actually. There is a possibility, and that actually our approach is that the data stays at the premises of the operator. So if that is a distribution system operator with 200,000 smart meters, then we don't copy everything to the blockchain. Actually, it stays there. The permission and handling is done here, and the traditional transport methods are used to send the data from the DSO to the service provider. So don't put all the data in the blockchain. It doesn't scale at one point and also has other problems. What is the second part of your question of how do we secure the smart meters? This is a good question. We have part of the SOFIE also interaction with the smart meters themselves to provide some additional security measures, starting with the creation of the ID of the smart meter. There is ways to do that using the physical unclonable functions on top of the chip that provides this ID that is not stored in some outside premises that can be more easily attacked. And with the use of KSM blockchain technology in combination with Buffy, we also can provide this data flow to the end user, providing only protecting the hashes of the data, but being able to prove that this data that was at that second collected from the smart meter, that this, when reached from the service provider dashboard, that you can be sure that this is that time and this amount of kilowatt hours. Okay?
So, thank you very much. If there is no other question right now, thank you, Prit. And the next presentation and the next pilot will be by Giuseppe Raveduto. It will be another energy pilot. So please, Giuseppe.
Thank you, George. Hello, everybody. Okay, here we are. Sorry. So I'm Giuseppe Raveduto from Ingegneria Informatica. It's an Italian system integrator, and I will present you the energy flexibility marketplace pilot. I won't bore you with technical details, I swear, but let me first introduce the context of our pilot and what is the pain that we are trying to solve with this solution. So, the traditional electrical grid was built with unidirectional power flow in mind. Now the trend is to have many decentralized and renewable energy sources in the grid. And while this is good, on the other hand, it's more complicated for the distributor to balance the grid. Because if you think of the typical solar panel production curve, is almost the opposite curve that the load of apartment consumes, because we have more production in the central hour of the day, and we need to balance this production, otherwise it's difficult to store it and cannot be transmitted at long distance. So this can create a stability problem and safety problems to the grid. So what we are trying to do is to use the electrical vehicle as a means to balance this surplus of production locally. So while the distributor sees the rise of this kind of problem, can ask to electrical vehicle user to recharge its vehicle in a predetermined zone and defined time window. So how is SOFIE helping us doing this? We can see here the system, the siloed system that we are operating over. So one side we have the distribution service system operator, that in this case is ASM Terni and provides the smart meters. On the other hand, we have Emotion, that is another Italian company that provides electrical vehicles and charging station and acts in our case as a fleet manager. Thanks to the SOFIE adapters, we can onboard this silos in the SOFIE platform, and the outcome are the decentralized flexibility trading marketplace that we will see in a few minutes, and the two dashboards that will be used for the two actors. More in detail, we can see here how the actors operate. So we have on one side the DSO that operates with, on the marketplace with the fleet manager and provide so for flexibility provisioning. On the other hand, since the DSO is not allowed to sell directly the electric energy, the fleet manager operates also on the marketplace to find the most convenient retailer using the same mechanism. So we can see here how the DSOs and the fleet manager dashboards are built on top of the SOFIE components. And so the federation adapter mentioned before, the components in charge of the semantic representation or identity authentication authorization, the marketplace component, and the Interledger capabilities. So what is the typical workflow that we have in mind in this case? So the DSO operator can monitor the occurrence of this problem, the reverse power flow, using the forecast provided by the dashboard. The dashboard can calculate this forecast accessing to data that come from the smart meters on the grid, and so this is where the federation adapter, for example, took place. Then, based on the output of the forecast, the operator can create a flexibility request on the marketplace, and it's an auction-like mechanism in which he identifies a particular zone and a time window, and also a related incentive in tokens, and asks to the market participants who is interested in take this the request and fulfill this request. So the fleet manager operator, on the other hand, will check his dashboard from request from the DSO, and in case it's suitable for its needs, it can matching the open request with an offer on the marketplace. So once the deadline associated with the request is met, the smart contract select the winning offer, and so the market request is finalized. At this point, the fleet manager can use the same mechanism, so using another smart contract to select the most convenient energy retailer to fulfill the DSO request if he is the winner. And so during the delivery time window, the grid is monitored thanks to the smart meters, the IoT smart meters connected, and so they act as an oracle for the smart contract. And once the agreed quantity of energy is recharged, the smart meters unlock the payment from the DSO to the fleet manager, and also in the same way from the fleet manager to the energy retailer. So, what we are demonstrating with this pilot is how to build a tamper-proof solution to manage a near real-time flexibility marketplace, how we can use smart contract-based authentication for the different roles, for example, and the cross-platform interoperability, because also George mentioned before, we are operating in a way that none of the actors has to change its existing platform, and providing a rapid user-friendly mechanism to negotiate on-the-fly micro-contracts. So the fleet manager in the previous example is not linked to a fixed contract with an energy retailer, but it's selected each time based on the most convenient one. So for the energy actors and the electric mobility actors, what we provide is the the possibility to use real-time and historical data to forecast the occurrence of problems for the DSO, help to recharge the batteries of a fleet of electrical vehicles at advantageous price for the fleet manager, and both use this flexibility marketplace to balance the local energy supply. So here I can show you some example of the dashboard. So we can see here how data from the smart meters are used to show the actual values and the forecasted value. Based on the values here, the DSO operator can identify the emergence of a problem of excessive load, and can create, using the form there, market request. So we can see, for example, a market request created, different market requests created by the DSO, and the associated offers from the fleet managers. On the other hand, we can see here the fleet manager dashboard. So on the right side, you can see the currently active campaigns from the DSO. So from there, the fleet manager operator can select what is suitable for him and participate to the auction. You can see here how the IoT system are used to provide information to the system. So, for example, the charging station and electrical vehicle data in real time. And here, this is the delivery window in which we are monitoring how the request is going, the amount of token, the agreed quantity, and the real-time data about the quantity actually charged. So the finalization, in which we can see how the token payment is unlocked after the vehicle is charged, and token can be used managed by using any standard wallet. And here an example of how we identified the main attributes to be used for our marketplace. So the attributes based for this specific case. We are extending the general smart contract, the marketplace provided by SOFIE. So it's not only the usage of a smart contract, but SOFIE provides a mechanism to easily extend those smart contracts and to adapt, as you can see, for example, to the specific case. Oh, and finally, many of you probably recognize this. This is from my development setup, so it's not real data, but how the it goes when transactions are recorded on the underlying blockchain. So, thank you.
Thank you very much, Giuseppe. Is there any question for Giuseppe right now? There is one over there. Wait for a second for the mic. No, just a second. Thank you.
Yeah, I just wanted to clarify with regard to the wallet. So does each electric vehicle have its own wallet that is then conducting the transactions, or is that all done through one general wallet of the fleet manager?
Okay, this is we are operating in a two steps process. In this case, I mentioned the fleet manager because we are operating with fleet managers, so the wallet is a fleet manager wallet that is used. Didn't show it in the screens, but for example, is the same balance that is used to make requests for the retailers, for example. So in this case, it's a wallet that is for the fleet manager operator. The second use case we defined involves directly the end user, and in that case, the wallet is for each user.
Thank you, Giuseppe. And the next pilot is going to be about the food supply chain and will be presented by Artemis Tomaras from Synelixis. Artemis.
Thank you. Hello. So my name is Artemis Tomaras. I am a software engineer at Synelixis, and I will be presenting the food supply chain pilot for the SOFIE project. In the pilot, Synelixis and Optimum are partners, and we have a cooperation, an end user, 7 Grapes, which is a producer association in Kyato, Greece. So, the objective of the pilot is to provide all the participating actors, mainly producers, transporters, supermarket employees, and the end consumer, with a way to reliably track product, verify, and receive information from the whole full supply chain, mainly from the field to the fork. How do we achieve that? Well, we split the supply chain path into segments: producer, transportation, storage and distribution, and supermarket. We use RFID enhanced boxes and sensors to track product information as well as the handovers between the actors. We also utilize DLTs to tamper-proof product information. So, these are the 5 steps of the business activities in our pilot. We start off with producers. Okay? Producers grow their product. In the scope of the pilot, the product is grapes, but it can also be any other type of product. So, in the field, we use the Synfield IoT platform, a smart agriculture and irrigation solution developed by Synelixis. We use it to monitor production conditions such as temperature, humidity, precipitation, and relevant product metrics. For example, what we do is we measure the ripening level of the grapes. When the product is ready, it is harvested and it is placed inside boxes. The boxes are then ready to be transported to the warehouse. For transportation, step 2, we have deployed an IoT platform based on the Ka IoT platform. We use it to monitor transportation conditions, for example, temperature, and to measure the transportation duration. Okay. So, in the warehouse segment, the boxes are placed inside a sub-department of the warehouse. The product is packetized. Packetized means the label that you see in the supermarket. And in this environment, we use Aberon, an IoT platform by Optimum. It's a warehouse management system, and we use it to aggregate and measure temperature and humidity conditions of the product inside the warehouse. After that, the product, the box, is ready again to be transported now to the supermarket. The 4th step is identical to the second, meaning that we use the same IoT platform. But of course, the driver or the transportation vehicle can be different, the fleet of vehicles, okay? So that's not a problem. Now, in the scope of the supermarket, products are placed on the shelf along with a generated QR code that shows the product history from the beginning, from the farm to the end. The main point here is to understand that the asset in the pilot is the box that contains the product and is uniquely identified by an RFID tag attached to the box. So, value proposition of the project. So, our business platform offers 2 main services to the participating actors. These are product traceability and an auditing service. By using the SOFIE Federation architecture and the components, mentioned before. Our system automates transactions over heterogeneous IoT ecosystems, introduces a flexible data adaptation layer to scale up federation of IoT platforms. I'll talk on that a bit later. We increase traceability of products and ensure integrity of critical data without the need of a centralized authority by using DLTs. And we increase transparency and trust in auditing process, let's say in case of quality issues, by also using DLTs and the SOFIE Interledger component. Okay. So, this is the high-level architecture of our system right now. We utilize two Ethereum ledgers. One is consortium-based, and the other is the public ledger. So, some more key aspects. Yes, as I said already, we have three IoT platforms. The communication between the IoT platforms and the supervisor goes through the federation adapters. They implement the Web of Things description model, W3C standard, to enable interoperability over federated IoT platforms. Okay, also, we have the supervisor component, which is part of the pilot supplementary services, that is basically, that handles flow from the adapters and is the backend of the web application that the actors interact with. Okay? Yes, one thing to mention is that our consortium ledger is a private Ethereum network, so data written to it is not public. Okay? The web app uses a role-based and token-based access control scheme. We also have deployed a smart contract in the consortium ledger, and actor activities through the web app generate Ethereum contract events in the ledger. Okay? Once the product is in the destination, the supermarket, we gather all the generated transaction hashes, and they are relayed to the public ledger via the SOFIE Interledger component. So, this is the list of the actions that the actors can perform in the system. Again, I will not be showcasing the web app. I don't have time for it. We can do it in the SOFIE booth downstairs. So, now here, the color denotes the type of actor. Okay? These actions are also in a timeline. They follow a logical timeline. And the operations describe roughly the backend actions that take place. For example, a transporter can register a box session. What this means is that the boxes are assigned to a producer. So imagine us generating an Ethereum event describing that the actor A, which is a transporter, assigned box B to a producer. Okay? Also, to name a few others, we have handovers. It's important to to register the handovers between the actors. And you see all the way down to the QR creation. The QR is created by the supermarket employee, and it is placed on the package of the product. So, summaries. We demonstrated some technical features such as secure and efficient creation of tamper-proof logs for chain activities. One important thing here is to say that, which may not be clear, that boxes are reusable. In that, when a box session starts, it is given a session inside the smart contract, and it is identified, and the session is closed when the box is at the supermarket. Okay. So, role-based access control and smart contract-based authentication happens in every of the previous step. We have common data formats for cross-platform maximum interoperability, Web of Things, and So, the main benefits to the food supply chain domain are the acceleration of digitization, automation, collaboration, and information sharing in the food supply ecosystem, which is a bit lacking, so to say. proof of product ownership and responsibility without the need for a central authority, and the enhancement of transparency and trust between the parties. Thank you.
Thank you very much. There's already a question
Yes, I'm sure.
there.
Hi, congrats on the work done
Thank you.
so far. I just had a question. How come you used Ethereum, and by that having to use one consortium chain, and then somehow obviously the intelligence component basically maps the ledger transactions into the public, so which incurs costs, instead of using something, I don't know, like Hyperledger, where you can have a public and a private side chain, so you can have a two-peg.
Yes, okay, understand. Okay, first of all, we keep data, the data that we keep, only in the private blockchain. Okay. Now, as you said, the events generated, you know, these are you can imagine these as smart contract events, have a transaction hash. So we relay the hash to the public ledger. Now, the public ledger at this moment is the testnet. Okay, so there's not actually any costs, either proof of authority or proof of work. Maybe we're considering with Guardtime to include KSI in the process at some point.
If I can add, before we go to the other questions, various different ways can be done here, and we are considering them in the project. But the important thing is to see that in a real world application, there are many actors, many types of actors with conflicting interests that want to get some information, some data revealed to some part of the world, and other data that needs to be private or auditable under some specific conditions. And this is what we are trying to do with the multiple different types of ledgers. And we could do, and we are looking actually at using Hyperledger Fabric for part of the system. And actually, even multiple transportation companies can be in this setting, and they might have already their own infrastructure going in one direction or another. And this is why we want to have Interledger to be able to enclose all of those, possibly. There's one more question over there.
Thanks for the very clear presentation. I was wondering how you compare to existing implementation within the supply chain, like Food Trust or provenance.org, and what is the extra benefits that you provide?
Okay, so some of the extra benefits are that we use the Interledger component of SOFIE. This is a main component of SOFIE. And we also federate different IoT platforms. I'm not sure if the mentioned companies actually do that. I could be wrong.
One more question over there. Sorry.
So you said you're using IoT platforms to monitor the temperature during transportation.
Correct.
My question for these is always, what stops me from putting a bag of ice on the IoT platform and making the temperature the correct one when inside the truck it's not? So just oracles are outside the blockchain, you cannot trust them. How do you solve this problem?
Well, in this pilot, if the aggregated temperature information is wrong, then this will be relayed to the consortium ledger. I don't know how we can stop someone putting a pack of ice inside a transportation vehicle, to be honest.
We don't have a solution for this problem, but there are some things that can be said about this. For example, you can check the temperature from multiple points from different actors, particularly for the handoff. And you can check other things, but you cannot really solve the problem that you mentioned, all kinds of tricks. That's the real problem with the real world connecting with the cyber world. But part of this is to have decentralized oracles. Maybe multiple players being part of the oracles, not necessarily for the temperature of the grapes, but for other more important events. And maybe we should move on to the last pilot that we have to present for you. It will be by Max Samarin and Ahsan Manzoor from Rovio Entertainment, and it will be on gaming with context sensitive.
Thank you, George. Does this work? Well, hi, everybody. I am Max Samarin from Rovio Entertainment, and this is the presentation about our pilot for the SOFIE collaborative project. And our pilot is about exploring how distributed ledger technologies and the Internet of Things could be used in mobile gaming. So first, in this presentation, we'll briefly talk about the potential use cases of blockchain and IoT in games. Then we'll talk about the scavenger hunt game prototype that we have made to test this. And then Ahsan will also talk more about the SOFIE architecture and the components that we use from the SOFIE framework to aid in our pilot. And then in the end, we'll also talk about our next steps in this research project. So indeed, this is a research project from Rovio, and with this, we aim to understand what kind of use cases there are from blockchain and IoT in gaming. And we want to test those use cases to see if they make any sense. And we do this in a very iterative fashion, which is very inherent to games. We see what works and what does not work. So what is IoT gaming? One use case is to use IoT devices for location-based games. So that means that, for example, Bluetooth beacons that can position players. So in such IoT games, there would be many actors involved. So we would have the players themselves who play the games, they earn the rewards, and then they can trade the rewards. We also have the game developers who create different games that use the same existing IoT beacons in the world. We also have the different businesses who serve as points of interest. These are the checkpoints in the games that players have to visit physically. And also we have the holders of the IoT devices, which are not always the same thing as the points of interest. So these are people who have existing IoT devices, for example, temperature meters, moisture meters, and they could also use these, for example, for games. And they could receive automatic micropayments through blockchain for their usage in games as well. So as we can see, in this scenario, there would be many different actors involved, and it's worthwhile to research if such an ecosystem could be built on an automated blockchain platform. So that's one use case. Some other potential use cases, for example, if cryptocurrencies become a more mainstream method of payments in general, that's something that games could support in their in-app purchases. Also, we could store the players' progress in games outside the games themselves on a blockchain. So if a game is, for example, discontinued, the player would still preserve some kind of value from the time they have invested into the game. Then there's also basic trading, and it's also even possible for different games to share the same assets between games through the blockchain, the same non-fungible tokens. And different games could, for example, interpret these tokens' DNA in different ways, however they want. As for IoT, especially indoors, it can be more accurate positioning than GPS, especially if you want to know which floor the user is on. GPS altitude is not that good there anymore. And Bluetooth beacons are also more difficult to spoof, so that means less cheaters, which is a very important thing in competitive games, especially if there are some monetary rewards involved. So we can verify with a higher probability that the player was actually what they said they were. So our first game prototype is called Scavenger Hunt. It is a real location-based game prototype, which it can be compared to the Amazing Race in the sense that the users get clues and riddles on where they should go next. Then they visit that physical location, and when in the correct physical location, they get tasks on their mobile phone, and they do the task, and then they move forward. And in the end, they get rewards. And for example, different businesses could serve as checkpoints, as the real locations in the game. So a cafe for example, can design such a hunt that they are the last checkpoint in the game. The player, they play the hunt, and by the end of the hunt, they are already in the cafe, they get the rewards, and one of the rewards could be, for example, a discount voucher, non-fungible token that they get, which they can use right there in the cafe, or they can sell it forward for real value. This is some screenshots about the game and the basic flow of the game. So first the player, they open the app and they see what kind of different hunts there are nearby based on GPS. They can browse what these hunts offer, how difficult they are, what kind of rewards they will get from them. And once they start hunting, there in the white box on the right, they can see the clue. So for example, in this hunt, it's about exploring a new city in the real world, so they have to find some statue. And once they find that statue in the real world, the box turns green and they get asked a question which they can answer by observing their surroundings. And once they complete all the steps, they get the rewards. So that's the basic idea. And how this was implemented, we're using a mobile game client which was made on Unity. And the mobile game client senses the Bluetooth beacons for positioning. Then that game client is connected to the more traditional game server, which then is communicating with the managed blockchain on Hyperledger Fabric. So it's not a game that runs on blockchain. It is a game that runs on a game server like usually, but for some features it uses the blockchain where there might be some benefits. For example, Hyperledger, it executes some logic of the transactions and the rewards of the game. And when we do our further use cases, when we test our further use cases, we could use the same Hyperledger blockchain if we want them, for example, to share the same assets between different use cases. And also, we will try to incorporate a public blockchain for item trading. And the connection between these two blockchains would be possible thanks to the SOFIE Interledger component. So we indeed do operate within the framework of SOFIE, and now Ahsan will talk more about that.
Thank you. Thank you, Max. Hello, I'm Ahsan from Rovio. I will be telling about the SOFIE platform and mainly specific to the gaming pilot architecture. On the right-hand side, you can see a blue dotted box, which is a traditional game server, which actually includes different DLT services and the local storage, which is connected to the games and the web applications using APIs. On the left-hand side, you can see the SOFIE platform, which George has already explained to you. We are using 5 different components to actually enhance the player's experience and to introduce new use cases for the gaming. I will be telling you in detail about all these components, how we are utilizing them inside the gaming pilot. The first one which we are using is discovery and provisioning. By this we mean actually we are using IoT beacons to for proximity locations of the player. But it's not impossible to actually, for one gaming company to deploy IoT beacons all over the world. So we needed to find that how can we discover new beacons which are already been deployed. There are millions of already deployed Web of Things devices. So we needed to find a way to to discover them up and then later provision them up and then configure them to be used as beacons inside the gaming pilot. So we came to the solution that mobile phones are already being used for playing the game. So why don't we use different sensors to actually sense nearby devices using Bluetooth, DNS discoveries, and to discover those beacons. And then we are using semantic descriptions, which use Web of Things description to look at what their capabilities are. On the right-hand side, there's a template of a Web of Things description that the service is provided by, and we can remotely configure those devices to fit our application in the gaming one. This whole component is provided by the SOFIE platform. The other two components which we are using is Interledger, the SOFIE Interledger, and the marketplace. Obviously, George has already told you that Interledger component will enable communication between distributed ledgers. In this specific mobile gaming pilot, we are bridging the gap between permission Hyperledger Fabric and public Ethereum network. We are linking the closed game ecosystem to a public ecosystems for trading of the virtual assets. This is mainly achieved by emitting and receiving events on smart contracts. The SOFIE marketplace component, as I've already told you, will be mainly used for in-game trading of the in-game virtual assets, which could be coins, gems, or any even user-generated content, skins or characters. I will be explaining about the benefits which the gaming pilot will be taking from the SOFIE components. The first one, discovery and provisioning. We can, as I've already told you, take advantage of already deployed Web of Things. And obviously, it creates new business opportunities for device holders. They could be compensated for the services used, and this whole process can be trusted and automated through DLTs. Then the semantic representation to actually introduce interoperability between the different Web of Things devices or IoT devices, and to unify those devices to be used as beacon in the game. Interledger, again, new business opportunities will be opened as closed platforms can be connected. For our specific gaming pilot, we take benefits from specific ledgers. We are using Hyperledger Fabric for its throughput and privacy, and Ethereum for security and traceability. The SOFIE marketplace is used. The benefit of using the SOFIE marketplace is that we can have the in-app assets could have some real-world value. To give an example of this thing is that if somebody gets a reward, a character or something, he could actually trade with the electricity or something else. So the rewards which they are getting inside the game would contain some monetary value. We are still testing that, that the SOFIE marketplace. In the end, the SOFIE identification authorization component, we are looking into how to use how a single decentralized identifier could be used for multiple ledgers. We don't need our players to have multiple wallets for each one of those ledgers, just one single decentralized identity, and they could perform on multiple ledgers, and the same identity will be used on public Ethereum or Hyperledger Fabric. Max will be now telling you about the future steps of our gaming pilot.
Thanks, Ahsan. So, yes, as for our next steps, we want to experiment with new use cases, and we want to find fun games so that we try to overcome the challenge so that blockchain doesn't stand in the way of players having fun in the game. So that's a challenge that we are exploring to solve. And also we will utilize more SOFIE components, the ones Ahsan talked about, so develop discovery and provisioning further to discover, so how to discover the existing IoT devices to be used in games, develop the Interledger component further, how to integrate different ledgers together, explore how we could use the IAA component as well as integrating the marketplace. So thank you. This was our presentation, and we would gladly now take your questions and any feedback that you might have for our implementation. Thank you.
Thank you. We have already a question there. Please wait for the mic.
Hello. I was a bit puzzled by the discovery and provisioning part of your architecture. And why is that? I'm not sure how and why you're using it. And I want to ask, it's a two-part question. First, if you delved into it because it's, let's say, a prerequisite or in the spirit of SOFIE to decentralize the hardware, or if it's part of your business logic, your game logic. And the problem that I find with this is that the beacons are mobile, they're movable. So maybe you discover and provision, and in 5 minutes it's a total different scenario. If you know what I mean.
Okay, the thing is, this is a research project, and we are looking into that in different use cases of IoT gaming. In this specific purpose, we are using IoT beacons to actually for proximity location of the players. So if you're going towards IoT beacons, it's not possible for a single company to deploy beacons all over the world. It would be too much expensive for that. So, and we, obviously, beacons have its own benefits for spoofing and other stuff. Now, for the discovery part, you're saying that if the person, I mean, we are discovering using the mobile, he's moving, and if there's a beacon nearby. Oh, the beacon is not, okay, then obviously if that beacon is moving and it does not provide the services which we need, we won't be provisioning into our database that could be later used to create hunts. So only those beacons will be provisioned into the databases which are actually, so at some point we know the locations and stuff, and when those devices will be discovered and provisioned. That's what the semantic representation will be used for actually bridging the gap between that. We will be reading the semantic description files to figure out what capabilities these IoT beacons will be providing, and if it's suitable for us to be used in future for providing, to be giving a location. So a beacon which is moving, obviously in its description file, it will be written that, okay, this is a movable beacon in a truck or somewhere, which will be moving from places to places. We won't be provisioning that device so that it not later be used for creation of the hunts. So I hope, I cleared the answer.
Sorry, the second part. And the
Sorry.
So the second part I want to ask is, I think you might have answered it already. If you're having a verification procedure, like we have, blocks being verified in a blockchain in general, if you are, let's say, abstracting something similar for mapping out the IoT infrastructure that you're discovering and provisioning. Yeah. Thank you.
I'm sorry, can you repeat that? I didn't get the question.
If you're having a verification, a decentralized verification process for the IoT mapping of the device that you discover and provision.
Yeah. But we are not doing it in a decentralized way because you're provisioning them into the centralized databases for later being used for creating hunts and stuff.
Yeah, the data is centralized, but I mean, if every user is walking around with his mobile and he's setting data to be, let's say, processed by maybe centralized Oracle. Discovering the beacons wouldn't be affecting the game itself because obviously first will be discovered and then later somebody has to create hunts on those beacons and provide some tasks on those beacons. Discovering the beacons is just to actually increase our database of the IoT beacons, and then later those beacons could be used as a point of interest in the game. So the point is, if you're even discovering it decentralized, they will be just being added into the kind of a database which could later be used as a point of interest when somebody wants to create the hunt or something like that.
Let me add, yes, in the future we could have various filtering functions on the discovered beacons that could be decentralized or could be reputation based in order to see who agrees about this beacon being there and being what it says it is, etc. But right now we don't have that.
And another thing I would like to clear this, as this is a research product, we are looking into, currently we are using IoT beacons. There are other ways of also confirming that the player is at that point, such as using Wi-Fi's 82.AD, 11AD is currently being used to provide exact locations at some point. So that could be, again, this process is, again, an iterative process of research that figuring out that what could be the use cases of IoT gaming and DLT in mobile games.
Any other question? There is one question here. Just wait.
One question from my side. What I would be interested in, did you get any idea about, let's say, what is the impact or the cost of working between the ledgers in terms of performance, in terms of transaction costs? I think this is something which is relevant to the other use cases as well. However, since you are dealing and transacting with virtual goods, like, for example, gems, maybe you are extremely cost sensitive and would be affected.
That was one of the reasons. I think, George, the project which Vasilios did, looking into the Interledger and cost of using, the Interledger actually decreases the cost a lot of using, because if you're doing all the logic on public Ethereums or public networks, the cost will automatically increase for each and every transactions. That's why our main game logic is on Hyperledger Fabric or a permissioned network. And then later, when we are calling Interledger to move some information, we will be looking into as little information could be moved with as little cost possible to the other ledger. So that's, cost is obviously one of the reasons, and the other reason for which we are using is the benefit of permission networks, which is scalable. The throughput's a lot more than the public networks.
If I can add, this is a loaded question, because Interledger can be realized, can be implemented in many very different ways. So it could be a third party that charges for the service, but it could be also with very simple mechanisms that can be provided by the actors that have presence in multiple chains. And in that case, it's the mechanism itself is basically free. But then if it's one actor, then it's not as trustful. So if you want multiple actors, then maybe you need incentives to get them in, and then there is cost involved again. So we don't have a good answer, but we have the following. In general, using interledger technologies allows you to use much lower cost technologies for things that do not have to go on public blockchains. And doing this is easy, doable, etc. In particular, if you don't ask for very wide consensus for the transactions. That is, if you can do them yourselves between ledgers, or if you can get one party to transfer value or data between ledgers. So in general, we can get the transaction cost even lower than the lower one, because we actually exploit the best properties from whatever ledger we have available.
Cost savings come from proper system design.
Yes. Yes.
And also, like in addition to that, we have one step back that even before the permissioned hyperledger, we are still using the traditional game server, and we do everything possible there, and we only use the blockchain for the parts that will benefit from that. So that's also one place where we save from the costs there. Sorry.
Okay. Actually, I would like to close. Thank you very much. So I'll review some of the things we have already seen. SOFIE is about providing security and privacy properties through federation in IoT ecosystems. And we do this using interledger transactions to get openness, security, and data sovereignty. We are driven by the 4 pilots. The 4 pilots are cover a very wide spectrum. And we think it is important to do it that way. So we see what problems and what opportunities we have in real-life systems. So we are not building, that was the starting point, we are not building a SOFIE platform. We are building components that are common for all these systems. And at this point, we have separate platforms for each of the pilots. Those platforms essentially pre-existed. They are working in their domain, but we are getting DLTs into them. And we recognize that not one DLT will fit in each of the pilot's ecosystems. And therefore, we took the decision that we'll accept whatever makes sense, either because it's already established, that some of the players have already some DLTs, or plan or prefer some DLTs, and then others have different ones and they need to interoperate, or then even if they don't need to interoperate directly, we want perhaps global trust, and we have some different level, some public level ledger to put signatures and events on that ledger. So SOFIE provides a framework for components for decentralized identities, for interledger, for authentication and authorization, also being compatible with existing authorization and authentication frameworks, but extending them to include decentralized trust, and other components like the marketplace, etc., driven by what we have seen as examples. So a key technology is Interledger, and Interledger can be realized in various ways. And depending on the requirements, the ways, and what exactly security requirements you request, the cost could be different, and the properties and the type of system you have to implement could be different. As a summary for the whole effort, what we can say is we think that blockchains and distributed ledger technology will be enablers for an integrated IoT, a real Internet of Things. Because right now we have silos. It's not an Internet of Things. We have various things silos that try to avoid interconnecting with other silos, in part for security and privacy reasons. And we think that if we provide the right components for controlled interaction, that we will improve on that and will realize a real Internet of Things. And then further moving along, maybe contribute to the realization of the 4th generation business platforms, where essentially digital goods, digital commerce can be interchanged and marketed in an open way, so that there is no controlling entity in the market. So we have Apple with the Apple Store, the App Store, and Google that have very controlling positions in the markets they have. But there could be other markets that would strive to have, all the players being able to participate at the same level and be open with no barriers to new players getting in. So what DLTs and an Interledger can provide is automatic contract enforcement, creating trust between devices and systems with unplanned interactions, decentralized payments, and audit trails that we see in most of the pilots that we have. Interledger in particular, working with multiple DLTs can improve privacy by keeping data and even signatures for events private in private blockchains and not putting them in public blockchains, for example. Improve on cost, scalability, efficiency, performance by doing things compartmentalized. What can be done on private or DLTs with specific properties is done there. What needs to be done separately in public or global blockchains or DLTs, it's done there. And data and value can be interchanged between the two. So all our design is at this point driven by those the 4 pilots. This makes it grounded in real applications, and we think that in the end, and we hope that we'll have direct impact in those diverse industries. So we hope to have impact in supply chains, in the energy market, and the gaming market, perhaps. Of course, we haven't solved all the problems yet. There are tons of sustainability and business issues. There are problems with real-world events. They are not directly verifiable by smart contracts or blockchains. We need oracles, maybe distributed oracles. This creates issues, problems. Still performance issues in all kinds of DLTs, even though some are performing much better than others. Of course, if you put data on blockchains, if they are, in most cases, they are open. If they are encrypted, there is a key distribution issue. Interledger in general improves on that by having data put on separate blockchains and with more controlled access to them. But this is still an issue for research, and we're doing this. So before I take your questions, I would like to mention, first of all, that we have a booth down, and there are people there, and we'll be there tomorrow, so we can talk more about this. And we'll be really interested if you have use cases, either from those 4 specific use cases or domains or business areas, or even others that you think would benefit from what we are doing. We would like to hear from you and maybe get involved with you in some way. Okay? So we can do this at the booth, or later on just contact us some way, and would love to get in touch with you and continue. Of course, we are also publishing much of our research. One of the papers that we have is on Interledger approaches on IEEE access. It's open publication, so you have direct access. Other things also are relevant, some about disconnected from the internet operation, how this can be done, etc. So we have looked at various such things. So I'll stop here. I'll take your questions, and if I need to, I'll ask my friends to help with those. So thank you. Yes?
So from my understanding, you use the first level after the IoT communication is a private blockchain, and then some things go to the public blockchain. And my question for private blockchain is always, who runs the blockchain? Who are the nodes? Because you need a multitude of nodes to guarantee security and trust, etc.
Good question. So our thinking is the actors. So let's say in the supply chain, the food supply chain, there are, let's say, 5 different transportation companies that might play. And then there are 20 farms. And then there are, 2 supermarket chains, etc. So either 2 at a time, or one consortium of transportation companies, okay, they might be running their own private blockchain. Okay, and this is actually why we think that we cannot dictate, you run this. Okay, now there are multiple ways of doing this. It could be the transportation companies that run their blockchain, or 2 at a time. So you have Hyperledger Fabric, and half of the farms and most of the transportation companies are interoperating there. And then if you have events, handoffs between from the farm to the transportation company, you record it there. That's one way. If they have separate ways, separate blockchains for transportation and farms, then you need an Interledger component to essentially record an event that was seen on one chain and also on the other chain, and make sure that it is represented in both. So there are different ways of designing the system. And in the end, there might be just one or a few public blockchains that really get the attention, either for universal trust or payments or something like that. And we use this as the top level thing. Yes?
I just wanted to say, from a business model perspective, that I realized that you're considering if somebody else has a blockchain running, but this is not the case out in the market. So in order to get buy-in from the market, when they sign up to the service, let's say it's a service, they should programmatically deploy a node that they're the only ones that can control it. Otherwise, I agree with my friend here that the kind of control, even in a consortium blockchain, trying to make them to understand why they do what they do and deploy nodes, it's just not going to fly, right? So you need a way of onboarding them to the service, and by doing so, programmatically deploy a node that only they can have access to. I'm just saying in terms of buying to something like that.
I'll accept it. I'll have my friends that are closer to the business domain, to the business cases, decide on that. We can definitely have one or a few blockchains that are running, and you select getting into the service. You are part of that. I have no problem with that. However, I think as an academic, it should be otherwise. That is, if you're a serious player, you already have your plans, and you want to stick to them for various reasons. In particular, maybe you don't like this other blockchain because it's run by somebody else, your competitor perhaps. But we welcome all input and all criticism, because we are at this point where we are trying to see what makes sense in the real world, in real applications. And it's not trivial, but we have some real world examples. We want to generalize and see what, in the end, both ourselves, and mostly the industry partners, but also the European Union want us to sell whatever we're doing. So really we have an impact, provide some ideas that would be transferable to the market. Yes?
Maybe two quick ones, if I may. The first one is you selected Interledger. There are other protocols, Polkadot, you name them. Why did you select Interledger?
We didn't select the Interledger protocol. The Interledger protocol, as you say, it's one specific thing. We deal with all Interledger approaches. So timed hash locks, which could be a simple mechanism, effective for everything, is fine, and it's not the Interledger protocol. So depending on the situation, we have the right mechanism, okay? For example, in all our pilots, we are not using the Interledger protocol per se. We have other mechanisms that we do this. And actually, we describe the trade-offs and the opportunities, the various Interledger approaches in our paper. So, and it's probably the first academic survey paper about Interledger approaches and trying to describe them, and also to evaluate in some way what are the pluses and minuses of the various approaches.
That would be interesting. And the last one was, let's say, what do you think, let's say, how far is this research away from really industrialization?
Very good question. So we have pilots. They are from real industry applications. Maybe I'll have Prit tell you. I don't know. They are selling this thing.
Working? 1, 2. Yeah. I think it's difficult to answer because
Prit, come over here.
Yeah, which kind of solution you think? If you ask about the free energy data for the Europe, I would say we have 2-3 years of hard. It stopped? No. 2-3 years of hard work ahead of us to have some impact in the market. That we can already say that there is both the openness of the data and the service providers that are adapted, and the customers that also trust this technology, so to say, because it's not irrelevant to actually tell the common people to say, yeah, this is something that is proved mathematically, but now please start using it. And it's not like you just buy some eggs from the shop and then go and cook them. It's something that you actually most possibly never understand to the full extent, but you still use it, and so there is some adaptation to that, and this actually defines if they are going to pay for that, and this is for the energy pilot. I would say in some other SOFIE pilots, it's a similar roadmap that you have to take a very specific functionality, and maybe you can commercialize that in 6 months, and you get the revenues, and that's done with. But eventually, SOFIE ends in 2020, December, and by then we have a clear exploitation plan for next activities, and there can be a possibility that we look for investment and spin out some part of the SOFIE from the business perspective to the market. Okay.
I would say it really depends on the specific thing we have.
Yeah, and it really depends on the pilot. So, for example, from the Rovio perspective, we don't know what will happen in blockchain and games in the next year or the 2 next years. So, we want to learn from this and to learn what works and what not. So, we are not making a commercial blockchain game.
Any other question? If not, thank you very much. It has been great having you here. Thank you.